Hello there, this is an Algebra 1 video. It is Chapter 9, Section 5. And today we are going to learn how to solve quadratic equations by using the quadratic formula. Now in our previous lesson we learned how to complete the square. Well, I will tell you that the quadratic formula comes directly from the completing the square process. So I'm going to spend a few minutes right now deriving the quadratic formula for your viewing pleasure. I probably shouldn't tell you this, but I don't want you to be really scared. I'm not going to test you on this process. I am going to test you on making sure you know the formula, but I'm not going to test you on what I'm about to do right now. But I'm going to complete the square of this quadratic. This is the standard form quadratic, ax squared plus bx plus c equals 0. And then I am going to show you how we get the quadratic formula. And once we have the quadratic formula, I'm just going to show you how to use it. All right? So please don't fast forward your video because you're not going to be tested on this. I want you to pay attention and see if you can follow along, especially if you know how to complete the square. What I will do is most likely make this maybe be a piece of extra credit on an exam in the future. So the first thing you want to do, remember we said whenever you have a number in front of the x squared that's not 1, you want to divide by that first. So the very first thing I'm doing here is dividing everything by a. And so they're going to cancel, and I'm going to get x squared plus b over a x plus c over a. And of course 0 divided by anything is still 0, provided that a is not a 0. Alright, so now we're down to this step. The next thing we wanted to do is to make sure that there was a blank. So we want to move the c over a, we want to move this number to the other side. So now we're going to have x squared plus b over ax, and then we're going to have our blank. Nice. And then we're going to put over here negative c over a because we're going to subtract this c over a to the other side. So now we have our blank there. Now the next step is to take the middle term, which is right here, the b over a. So we're going to do that over here. Take the b over a, and we want to divide that by 2, remember? But when you divide by 2, it's the same thing as saying multiply by the reciprocal of 2, which is 1/2, which then gives us b over 2a. After I divide by 2, I want to square my results. Okay, so that means I'm going to have b squared and then 2 squared, which is 4, a squared. So I'm going to add b squared over 4a squared to the left-hand side, and to keep it balanced, I'm also going to add b squared over 4a squared to the right-hand side. Now remember what I said in the previous video, that the value before you squared it is always what goes in your perfect square binomial. So now I'm going to have x plus b over 2a quantity squared, that's the number inside here before I squared it, equal to, and I don't like starting with a negative value, so I'm going to start with the positive value. So I'm going to write this b squared over 4a squared minus c over a, just like that. All right, doesn't matter which order you write those in, as long as this is positive and this is negative. This is positive, this is negative, so we're all good. All right, and now we all probably know that when you want to combine fractions, you have to have a common denominator, which we don't have right now. So I'm going to multiply this fraction by 4a because the common denominator is 4a squared. So 4a times a will give me 4a squared. So now I can write this as x plus b over 2a quantity squared, and then I'm going to combine the top of the fractions, which is going to be b squared minus 4ac, all right, all divided by 4a squared. Nice. Now we have done the part that is completing the square. We have completed the square now, but we want to solve for x. So we're going to square root both sides, and when you square root a fraction, you square the top and the bottom. All right, so the square root and the square will cancel on the left hand side, and leave me with x plus b over 2a. On the right-hand side, the top portion here, because of the subtraction, cannot be canceled. You can't cancel this square with the square root because of this minus symbol. So I'm going to have the square root, and it's going to be plus or minus b squared minus 4ac. On the bottom, the square root of 4, see here you don't have any subtraction, so you can cancel the square root and the square for the a, and the square root of 4 is 2. So we end up with 2a. The square root of 4a squared is 2a. And our last step is to move the b over 2a to the other side because you want x by itself. So we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And since both of these fractions have the same denominator, which is 2a, we can now finally write the formula as x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. And believe it or not, this is the quadratic formula that we use to solve quadratics, provided you know the a value, the b value, and the c value of the quadratic in standard form. There's also a song that we sing, and you might think that that's a little lame or a little immature for your age level, but I will tell you that I have students even today that are in college emailing me, texting me all the time, telling me they're so grateful that I taught them the song because that is how they have remembered it. So if you know the tune of Jingle Bells, jingle bells, jingle all the way, oh, hey, right, that song? Okay, we're going to use the same melody, and we're going to sing this song. Now, if you're at home, no one's watching you, go ahead and sing it to your heart's content. You can follow me. I'll sing it a couple times so you can get the rhythm of it. Okay, it goes like this. X equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. See? Jingle bells. All right? So we'll do that one more time. X equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. All right, there's also another one that is not that great of a song. It goes, I'm not exactly sure what the name of the song is, the original version, but it goes something like x equals negative b plus or minus square root b squared minus 4ac, all over 2a. I think I like Pop Goes the Weasel, but seriously, that's not even as cool. So one more time, x equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. I hope you have enjoyed that. I have enjoyed it. And so now we're actually going to use the quadratic formula to actually get busy here solving these equations. All right, so here we go. It says solve x squared minus 12x equals negative 20 by using the quadratic formula. The first thing we need to do is write this little guy in standard form. So we're going to make sure that we take x squared minus 12x and bring this negative 20 to the other side so that the plus 20 equal to 0. You definitely want your quadratic to be in standard form equated to 0 before you begin. You also want to keep note of what a, b, and c are. In this case, a is 1, b is negative 12, and c is 20. Then you want to take the song I just showed you and plug it all in. X equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. All right, now we're actually going to plug in the values of a, b, and c. So here they are. X equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. So notice that when I said negative b, I put the negative and then parentheses for the b value. And since b happened to be negative 12, those are going to cancel out and make that a positive 12. So basically, another way of saying that is opposite b. All right, so you're going to get 12 plus or minus, and then in here, we know that negative 12 squared is 144. And so we're going to go 144, and we're going to say 4 times 1 is 4, and then 4 times 20 is 80. All right, so we're going to go 144. I'm going to get a calculator that actually works. 144 minus 80 is going to give us 64. So now what we have here is x equals 12 plus or minus the square root of 64 divided by 2. Since we know the square root of 64 is 8, we're going to get 12 plus or minus 8 divided by 2. So don't let this scare you. It just means that you want to go 12 plus 8, which is 20, and then 20 divided by 2. My pen dies sometimes. I'm not really sure why, but it does. There we go. So we have 20 divided by 2. And then you have 12 minus 8, which is 4 divided by 2. So your two answers are going to be 20 divided by 2, which is 10, and 4 divided by 2, which is 2. So you get two solutions, as you should with the quadratic, or most quadratics that is. So x equals 10 and 2 for this example. Alrighty. So now we're going to let you do this do-it-yourself question, and then we'll go on to example 2. All right, in example 2, we're doing the exact same thing, only this time, like in the previous example, what happened was you ended up with the square root of 64, which is a nice integer. Sometimes you get the square root of something crazy that's not a nice integer, and that's why it says, if necessary, you want you to round to the nearest tenth. All right, but this is already in standard form, and part B is not in standard form, so let's go ahead and put that one in standard form. We're going to get 10x squared minus 5x minus 25 equals 0, because we're going to move this positive 25 to the other side. It'll become negative 25. So that's the first thing you want to do. And then we're going to use our A value of 3, B value is 5, C value is negative 12. So we're going to say x equals negative b plus or, sorry, I put the wrong b. X equals negative b plus or minus radical b squared minus 4ac all divided by 2a. All right, so this time I went a little quicker here, so hopefully you were able to keep up. We have x equals negative b. This time b was positive 5, so we have negative 5. And then we had b squared, which is 5 squared, 25, minus 4 times a times c, all divided by 2a. So now we're going to get negative 5 plus or minus, and we have 25 minus 4 times 3, which is 12, and 12 times 12 is 144. So we're going to take 25 and add, because you have negative times a negative, that's positive. So we're going to have 25 plus 144, which is actually 169. So the square root of 169 all over 2 times 3, which is 6. Now the square root of 69 is actually 13. And so we have negative 5 plus or minus 13 divided by 6. So we're going to get two answers. We're going to have negative 5 plus 13, which is 8, divided by 6. So that's going to give us 4/3. 8 over 6 reduces to 4/3. And then we're going to have negative 5 minus 13, which is negative 18, divided by 6, which is negative 3. So our two solutions are 4/3 and negative 3. All right, so now we're going to do the exact same thing over here. And our A value this time is 10, B value is negative 5, and C value is negative 25. So we're going to say x equals negative b plus or minus radical b squared minus 4ac all divided by 2a. Okay? So again, we did negative b, which means opposite b. Since b was negative, it became a positive. And also negative 5 squared is still positive 25. And we have 4, A is 10, and C is negative 25. So here we have negative times negative is positive, and 4 times 25 is 100, and 100 times 10 is 1,000, and then we're going to add 25. So we're going to get 1,025. Plus or minus our 5's over here, divided by 20. Now the square root of 1025 is a decimal, and that's why it tells us to round to the nearest tenth if necessary. So at this point we're going to have 5 plus or minus, the square root of 1025 is roughly 32.0156. So we're going to round to the nearest tenth, which is 0.0. And then divide that by 20. So our two solutions will be 5 plus 32.0, and then divide that by 20. And we're going to get 1.85, or we're going to round to the nearest tenth, so we'll get 1.9. And then we're going to take 5 minus 32.0, and then divide that by 20. And that's going to give us negative 1.35, or we're rounding to the nearest tenth, which is negative 1.4. So our two solutions are positive 1.9 and negative 1.4. So now you will try these two, and then we will go on to our next example. And our next example is actually says solve x squared minus 4x equals 12. And actually, it doesn't indicate that we have to solve by using the quadratic formula. So at this point, in example 3, and even in the do-it-yourself number 3, you can choose whichever method you would like to solve the quadratic. You can solve it by graphing, you can solve it by factoring, you can solve it by completing the square, or you can solve it by using the quadratic formula. I am going to choose to solve this one by factoring today, just to be a little different from the completing the square. And so the first thing I want to do is write it in standard form. So we'll bring our 12 back to the other side. And then I'm going to use my little grid here. And I'll have 1x and 1x will give me x squared. And to get 12, I'm going to say 6 times 2 is 12. And if I want a negative 4, I will do negative 6x and a positive 2. So that I have negative 6x. And then I'll add that to a positive 2x. And that'll give me a negative 4x, which is what I need here in the middle. So these are the factors I'm going to want. So I will have x minus 6 and x plus 2 equal to 0. And if you recall how we solve by factoring, we take each factor individually. So x minus 6 equals 0, or x plus 2 equals 0. And in the case of x minus 6 equals 0, we will add 6 to both sides, and x will equal 6. In the case of x plus 2, we will subtract 2 from both sides, and x will equal negative 2. So my two solutions will be 6 and negative 2. Now remember that you can choose either of the 4 methods, either graphing, factoring, completing the square, or the quadratic formula for your way to solve these two here. Alrighty? So now I want to show you something that we have with the quadratic formula, which is the discriminant. Discriminant obviously coming from the root word discriminate, which is basically to set somebody apart or something apart based on some criteria. Obviously it can have a negative connotation, but in this case it's a very neutral connotation. It does help us distinguish between different types of solutions. So first of all, the discriminant is not the entire quadratic formula. It's only the part of the quadratic formula that goes underneath the square root. So when you sing the whole song, like negative b plus or minus radical b squared minus 4ac, that's the part. Just the b squared minus 4ac, okay? Just that. That is the only part of the discriminant, okay? And the discriminant helps us distinguish between having no x-intercepts, where it never crosses the x-axis, one x-intercept, where it kind of sits on the x-axis, or 2 x-intercepts where it distinctly crosses the x-axis in 2 different spots. Okay, which also means that that would be the solutions. Remember in our example earlier, we had a negative answer, it said equals -5. Sorry, not in our previous example, it was in the previous video. You ended up with square root of a binomial that was equal to a negative value, and we can't take the square root of a negative value. So that's why we have 0 real solutions when that happens. So when the discriminant is negative, the part that goes underneath the radical, when that value is negative, because we can't take the square root of a negative, we end up having 0 real solutions, because and then graphically that means there's no x-intercepts, and it would look something like this. You can also have b squared minus 4ac equals 0. If it equals 0, you will have a solution. You'll have one solution, because it'll be plus or minus 0, and when you add or subtract 0 from any number, you only get one option. Okay? If you think about the quadratic formula, it's plus or minus radical. So it's the plus or minus that basically causes you to have two solutions. And in the case of plus or minus 0, you only have one solution. It's where it sits on the graph like such. All right, and then of course if you have a positive value under the square root, that's where you get your two real solutions, and that's where you have two x-intercepts, and it looks like this. All right, so we're going to use the discriminant here. It says state the value of the discriminant. So they want the value of the discriminant. Then determine the number of real solutions of the equation. So first thing you want to do is write our quadratic in standard form, which it's not in right now. So we want to go 4x squared plus the 5x, but then the negative 3 needs to come to the left-hand side as a positive 3, equal to 0. Now remember that when it comes to the discriminant, you only want b squared minus 4ac. I always get students to try to plug the whole thing into the quadratic formula. You don't need to plug the whole thing into the quadratic formula. We just need b squared minus 4ac. So b squared minus 4ac. b squared is going to be 5. Okay, b squared minus 4a, a is 4, and c is 3. So we're going to get 25 minus 4 times 12, because 4 times 3 is 12. And 4 times 12 is going to be 25 minus 48. If it'll finish writing for me here. Hello, there we go. So 25 minus 48, because 4 times 12 is 48. And 25 minus 48 is going to give you negative 23. Not sure why that happened there. So first part of the question was to state the value of the discriminant. The value of the discriminant is negative 23. Because it's negative, and because of what we said earlier, that means that as far as the number of real solutions, this particular equation will have no real solutions. 0 real solutions, because it was a negative value. All right, and that's all you have to do. So now we'll let you do that for these two. And then once you have completed this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.